Okay, I have 6 minutes until the bell rings, so I'm going to get this done before that bell rings. You watch. Okay, first one, solve the system by elimination. So again, we are in systems of equations. So we're talking about where two lines are crossing. If you want to get the rest of these, if you want to get a better picture of these notes, look at my previous video. Solving systems by elimination. This is where you're adding two equations together to get rid of one of the variables. So in this case, the -4 and the 4 become a 0, and we can add the rest of the equations together. So that's 13x equals, and then 42 minus 3 is 39. Okay, oh, come on. We're not allowing that. Okay, so then you're going to have divide by 13, and you get x equals 3. So once you have what x is, you can substitute it back into either equation. It doesn't matter which one you pick. You could pick the first one, you could pick the second one. It doesn't really matter. I'm just going to pick the second one. So we have 3 times 3, and we're replacing that x, plus 4y equals -3. So multiply together, you got 9 plus 4y equals -3. Subtract 9 from both sides, and you get 4y equals -12. Divide by 4, y equals -12. Now you have your two solutions there. Okay, so you have 3, -12. All right, so if you're wondering where I got -12 from, I didn't say that. It's just that -3 minus 9 is -12. 3 negatives, 9 negatives, 12 negatives. Okay, now that that's solved, we're going to the next one. This one's really similar to the previous one in that you're looking for a 0, except y plus y is not 0. You've got to change one of these equations to a negative, and we'll just take that second one and we'll say if we make this y negative, then this will be a 0. But you can't just make y negative. You've got to change the signs of everything. So in that equation, so that's a -6 and that's a -3. So now x minus 3 is -2x. This is 0. And you have 12 minus 6, which is 6. Divide by -2. Divide by -2. X equals -3. You're halfway there. So let's use that first equation. We're going to say -3 plus y equals 12. So I got -3 here because this is x, right? And x, we just figured out, is -3. So we're substituting it back in for x. Add 3 to both sides. Oops. And you get a 0. Y equals 15. -3, 15. Okay? All right, so now that we know what that solution is, we're moving on to the next one. Next one is you have two problems here. There is no 0 here. So what you need to do is figure out which one you want to actually be 0. So I can make 3 and 5, 15, both 15s, and I can make 2 and -5, 10. I'm going to go with the 2 and the -5. So if I know that these two will go into 10, and I want this to be 10x, and I want this to be -10x, I've got to figure out what to multiply this equation by to get it to be -10. So in this case, I'm going to multiply everything by 2 because 2 times -5 is -10. So 2 times 5 is +10. And then 2 times 15 is 30. All right. And then the first equation, so I've got to multiply this by something to get it to be 10. So 2 times 5 is 10. So that's multiply everything by 5. 5 times 2 is 10. 5 times 3 is 15. And that equals -5. Now that they're all equal to each other, it's the same thing that we did up here. We make a 0, right? So we're making a 0 with the x here. So this is 25y. 15 plus 10 is 25. And then you have 30 minus 5 is 25. Divide by 25 on both sides. Oh, I'm going to run out of time. You have y equals 1. So once you know that y equals 1, you actually have 4 different equations that you can pick from. You could pick from this one, this one, this one, or this one, and they would all give you the same answer. So you have 2x, I'm just going to pick that first one, times 3 times 1 equals -1. I'm just taking my original equation right here and substituting the 1 in for y. Oh, there's the bell. Okay, so you have 2x plus 3 equals -1. I'm going to say bye to my TAs. Bye, TAs. Subtract 3 from both sides, and you get 2x equals -4. Hey, did you guys check it already? Okay. Divide by 2, x equals -2. So now we know that -2 and 1. Okay, that's our solution. Again, so just to review real quick on this one, because it is multiple steps here, you're looking for what do 2 and 5 both go into, and we're setting that up to be 0. Once we know that it's 10 and 10, because 5 goes into 10, and then 2 goes into 10, you have 5 times 2 is 10, 2 times -5 is -10, and then you're off to the races. Okay. All right. Okay, so next up, we have what I like to call the how many, how much problems. Okay, it's still systems of equations. So how many, how much. Okay, and they all kind of break down into these two equations. Like how many bags are we talking about of hardwood in this problem? And then how much are those bags of hardwood going to cost? And so the really good news on this problem is that this is like easy points, right? You don't even have to solve it. All I ask for is write this system of equations that can be used to solve this problem. You don't actually have to solve this one on the test. So I just want to know, can you recognize what it is and solve the problem? Okay, so it says a local boys club sold 176 bags of hardwood mulch and pine bark mulch. So there's 2 types of mulch, right? There's hardwood mulch and there's pine bark mulch. So we're going to say the number of bags equals the hardwood mulch, or H. Okay, sorry, my H looks awful. Plus the pine bark mulch of P, and that's gonna, those 2 number of bags, the how many bags, adds up to 176 bags. Okay, so we've got our first equation there. Okay, our second equation is our how much equation. This is what we're going to actually start talking about money. So if we've sold 176 bags, the boys club sold hardwood mulch for $3.50. The hardwood mulch for $3.50 a bag, and then pine bark mulch for $2.75 a bag, and then they made $520. So this one is just $520. Okay, and the hardwood mulch costs $3.50, so we're going to say 3.5 H plus 2.75. I'm just going to have to write small p. And there's our 2 equations. That's it. That's all you got to do. How many, how much? All right, next up, last but not least on our problems here, we have use a graph to make a linear model for each function. Describe the meaning in terms of the models. Then state what the solution represents. Okay, so we have the costs of something. So this is 2, 4, 6, 8, 10. So this is the amount of money that it costs. This is the number of dogs walked. So it looks like we're talking about 2 different companies here, company 1 and company 2. So company 1 has a starting fee, it looks like, of $4, and then they have a certain rate that they charge for the number of dogs, right, that they're walking. So it's a dog walking company. And then company 2 starts off at $2, and then they have a certain rate for the number of dogs that they charge, or that they walk. And so our job is to figure out what the equation is. And so this is just a linear equation. So the things that we need to figure out is, where are they starting? So for C1, which is this line right here, our y-intercept, so it's going to be C1 equals and then there's going to be something here, something next to n, and then their starting fee is at $4. Okay, and then after that, we've got to figure out our slope here. So we're going to have the number of dogs walked. So for every number of dogs walked, right, this one is going up by $2. So we have our rise of $2 and a run of $1. Okay, so 2 over 1. You don't have to put the 1 there. You could just put 2. For those of you saying, why don't you just put 2? Well, you could, but I wanted to show that we are rising by 2 and over by 1. So I want to show where that's coming from. Okay, so next up, we have company 2, and they are actually starting at a cheaper rate. So we're going to say equals whatever our slope is here. We'll come back and figure that later, n plus $2. And some of you might be saying, well, why are you putting n there? I usually see x there. That's because we have n is the number of dogs walked. So if it's n here, we should be using that same variable here. Okay, so you could think of it as x. Okay. All right. Up next, we got to figure out the slope of this equation. So we're going to go until we see another point, and we're going to pick that point. So we have a rise of $10 to get from here to here. So I'm going to say $10 over 4. And honestly, I would accept 10 over 4 here because that is a function. Is it simplified? No. If you wanted to simplify, you could and get 5 over 2, and we would say 5 over 2. I'd be okay with that. I would be okay if you put 4 over 10 here. I'd be okay if you put 5 over 2 here. I don't care about simplification in this case. I just need to know, can you identify where the starting point is, what the slope is, and write it in a function, okay? Now, let's say, what does the solution represent? In this case, it represents where both companies cost the same money. Okay, so this one is costing you $12. Company 1 is costing you $12. Company 2 is costing you $12. Okay, when is it better to go with company represented by the equation C1N? So here's C1N, right? And so it is better to go with them if you need them to walk. Well, they're cheaper up here, aren't they? So here we have company 1. If you have 7 dogs, company 1 is going to cost you $18. If you have 7 dogs for company 2, they're going to cost you about $20, right? So we want to go with company 1 after 4 dogs. So if you need more than 4 dogs walked. Okay, well, if you have 4 dogs at your house and need them all walked, you need to stop buying dogs. Okay, just saying. Anyway, that's your test. That's the systems of equations test. So your job now is to take what you've learned here, go to the packet here in review number 2, and your job is to start working on this packet on your own. Okay, I want to see what you can come up with on your own. Ask me questions in class on this review, and then once you have demonstrated that you've given it all on your review number 2, then I'll give you a test and I'll put time into grading that test. But you need to put the work in first by working on the second review. Okay, thank you for your time.